Hello, statistics. Here's chapter 7 homework. So the first question, again, 15 questions, 30 points, so 2 points each. So the whole assignment is worth the same amount as those first few, but now each question is worth a little bit more. A newspaper provided a snapshot illustrating poll results from 1,910 professionals who interview job applicants. The illustration shows 26% of them said the biggest interview turnoff is that the applicant did not make an effort to learn about the job or the company. The margin of error was given as plus or minus 3 percentage points. What important feature of the poll was omitted? So the point estimate, the sample size, the confidence interval, or the confidence level. So if I click on question L and go to my textbook, if I scroll through estimating population proportion, point estimate, sample proportion, so that's going to be what? That's going to be that 26% of them. The confidence interval, we can use a sample proportion to construct a confidence interval. Well, that's going to be what? That so we can look at that, and then sample size, how many of them? 1,910. So my margin of error was that plus or minus 3%. Well, that's what gives me that interval, right? 26% plus or minus 3, that's my interval. So I only have one thing left, and that's going to be my confidence level. It doesn't say 95%, 90%. What was this margin of error based on? So that's that the confidence level is the answer on this one. This guy expressed the confidence interval 0.777 is less than P is less than 0.999. And so what's going to happen is that E is going to be that margin of error. You have to plus or minus the same number from the number in the middle. So what number is exactly in the middle of 0.777 and 0.999? Well, it's 0.888. And how different is 0.888 from 0.777? It's 111 off. And it's also 111 above, so it's 111 below 0.999 and it's 111 above 0.777. If you go into view an example, you'll see the actual formula here. You add them together and divide by 2 in order to get your p hat, and then you can subtract the upper confidence minus lower confidence and divide by 2, or you can just take the upper confidence and subtract off that p. So this is another one that if you chose to, you could do with your calculator or you could do in Excel. They would both work. So here's another example. So express the confidence interval 0.018 to 0.110 on the form of p hat minus the error between p hat plus the error. And so remember, the smaller number goes first, that 0.018. The larger number goes next, 0.110. That's all they're looking for that problem. The next problem is use the sample data and confidence level given to complete parts A through D. A research institute poll asked respondents if they acted to annoy a bad driver. In the poll, N equals 2,488. That means they polled 2,488 people. X equals 993. 993 said they honked. Use a 99% confidence interval and then click on the icon here to see the value of z-scores. So my z-scores, so if I want to be 99% confident, you see down here, if you scroll all the way to the bottom, common critical values, 99%, we're going to use 2.575. So on this one, I am going to open this up in Excel. And as you see, I labeled the pieces already for you. So X equals 993, so that's this piece. N equals 2,488, that's my total. P equals 0.399. How did I find that? Well, remember, X divided by N. Probabilities always have to be between 0 and 1. So if you accidentally divided 2,488 divided by 933, you would have gotten a number more than 1. Q is always 1 minus P. So 1 minus 0.399 is my Q, which is 0.601. I need that. And my Z is 2.575. We took that from the table up here. And remember, we went all the way down on the bottom of the page. So my E, the way I'm going to find my error here, it's my z-score multiplied by the square root of P times Q divided by N. So here's the formula I typed in. I did round it to 3. I also rounded the P to 3 as well, because that's how they wanted the numbers, rounded to 3 decimal places. My confidence interval is going to be P minus E. So my P that I calculated, take away my margin of error, and then the upper side of the bound is going to be my probability P plus my margin of error. I didn't have to round out to 3 because I rounded both the pieces to 3. So when they asked for my P, that's my 0.399. They also asked for my error E, which is this piece right here, 0.025. And they actually wanted that to 4 decimal places. So I'm going to come in here, change my 3 to a 4, and there's my 0.0253. And then here's my interval, 0.374 to 0.424. Write a statement that clearly interprets the confidence interval. One has a 99% confidence that the interval from the lower bound to the upper bound actually does contain the true value of the population proportion. Which concept below is not a main idea of estimating population proportion? Not a main idea is using a sample statistic to estimate the population proportion utilizing descriptive statistics. That's not a main idea. Main ideas are knowing the sample size necessary to estimate the population. What is the N? What can we use a sample proportion to construct a confidence interval to estimate a true value of the population proportion? That's what we're trying to do. And the sample proportion is the best point estimate of the population proportion. If you have nothing else, the sample becomes the population estimate. It's the same as the mean. The sample mean becomes the population mean estimate because that's all we know. So which of the following groups has terms that can be used interchangeably with others? Percentage, probability, and proportion. They all have to be between 0 and 1. They all have to be, they're all probabilities, percentages, proportions. Notice critical value. Your critical value is your Z value. That's your Z. That's the number that you look up to get that percentage. Which of the following is not true of the confidence level of a confidence interval? It's not true that there is a 1 minus alpha chance where alpha is a complement of the confidence interval that the true value of P will fall in the confidence interval produced from our sample. You're never sure that it's going to happen. So the true value of P, you're alpha sure that it will. So what is true? Confidence level gives us success rate of the procedure used to construct the confidence interval. Confidence level is also called the degree of confidence. Confidence level is expressed as a probability or area 1 minus alpha, where alpha is the complement of the confidence interval. Which of the following is not needed to determine the minimum sample space required to estimate a population proportion? Standard deviation. You do need a margin of error. You need the Z-score. You also need your alpha, how confident you are. You do not need a standard deviation to determine the minimum sample size required to estimate the population proportion. Do one of the following as appropriate. Find the critical Z alpha over 2, critical T alpha over 2. State neither the normal or the T distribution applies. So the confidence level of 98%, N equals 23. The population standard deviation is known. Population appears to be very skewed. So neither the normal nor the T applies. Note that we have N equals 23, so it's smaller than 30, but the population standard deviation is known, so that means we could have used the Z, but the population appears to be very skewed. Well, you can't use a Z because the population is very skewed. So one thing that I would recommend while you're on this question number 9 here is click on the value of critical T values, and you see this little box right here. Open it in Excel. If you open it in Excel, you have your T table. The normal table you can do the same thing with, so open that in Excel, and page 2, because you're going to have a positive page and a negative page. My recommendation would be to have those open in Excel so you can use them for the future questions. Hi, so this one, number 10, use the technology in the given confidence interval, sample data to find the confidence interval for the population mean mu. Assume the population does not exhibit a normal distribution. We know we want 90%, N equals 41, X bar is 4, and the sample standard deviation is 6.4. We're going to need a T, so we're going to use that T table. If you want the formula, so it's going to be X bar plus or minus E, which E is the T times the standard deviation divided by the square root of N. You can always pull that up and view an example. So we are going to pull up that T table. Remember how I saved that T table in Excel? The reason I did that was because I knew I was going to need it. So if N is 41, my degrees of freedom is 41 minus 1, which is 40. So I need this column right here. And then the next thing I'm going to need is I need a 90% confidence interval. Area in one tail is going to be 0.05 or that 0.1 in both tails, 90%. So that's going to be 1.684 is going to be that T that I need because 90%, 10% left over, 1.684. So my T is going to be 1.684. My S I put in here as 6.4. That came from here. X bar is 4 and N is 41. So I need to calculate my E. Remember, my E is going to be what? That's going to be my T, 1.684, times my S, which is 6.4, divided by the square root of N, which is 41. Here's the formula in Excel. I also rounded it to 1 decimal place. So my E is going to be 1.7. So when I do my X bar, which is 4, minus E of 1.7, that's going to be 2.3. X bar 4 plus 1.7 is 5.7. Is the confidence interval affected by the fact that the data appears to form a population that is normally distributed? And so the answer choices are, so I had to close out and come back in. So it is a slightly different question with different answers, but it is still no because the sample size is large enough. So on this one, a physician wants to develop criteria for determining whether a patient's pulse rate is atypical, and she wants to determine whether there are significant differences between male and female. Use the sample pulse rates below. So we're going to have a sample of males and we're going to have a sample of females. They're going to want us to construct a 95% confidence interval of the mean pulse rate for males and the mean pulse rate for females. So this is where I'm going to start showing you a little bit of the easier way to do it. So if I click on here, open in StatCrunch, I already pulled up the data in StatCrunch for you because it takes a little bit. I'm going to go to Stat. This is a T-Stat. Why is it a T-Stat? Because it's a sample. I have less than 30. I'm going to do one stat with data because I want one statistic for each of them. I need to select both columns because I need both of them. I'm going to click on confidence level, and it is a 95%, so 0.95. And I'm going to compute. My lower limit for the males is 60.7, and they do want it to 1 decimal place, so 60.7. Upper limit 79.3. 2 next to the 2 is a 7, which is 5 or above, 79.3. For the females, the next part of the question is asking for females, so that's going to be my 78.2. Next to the 2 is a 3, so it stays as the 2. 100.2, next to the 1 is a 6, so it has to go up. And then compare the preceding results. Can we conclude that the population means for males and females are different? No, because the two confidence intervals overlap. 79.3 is the upper for the males and 78.2 is the lower for females. So this one wants me to estimate the number, the sample size required. This is another one. If you want the formula quickly, view an example. N equals the z-score times the standard deviation divided by the error, and that entire thing squared. So remember how I told you I was going to save my z-tables and my t-tables from number 4? It's in Excel here. So I'm on my z-table. 90% my z is 1.645. I'm going to jump into another Excel file. My z is 1.645. The population standard deviation is 211. That is right here in the problem. Standard deviation of the population monthly time spent is 211. And then my sample mean is within 15 minutes of the population. That means that that's my error. They're willing to be within 15 minutes. So my E is 15. My formula is going to be what? It's going to be my Z. And then we're going to multiply that by my population standard deviation divided by n, and then I need to square the whole thing. So if you're using a calculator, 1.645 times 211 equals, divided by 15 equals, and then square it. My answer is going to be 535.4. What's going to happen is you cannot have the half a piece. So you always have to round your sample size up to the next